Hey everyone, I'm Justin Woodring. Today I'll be showing you how you can approximate pi using an interesting technique known as the Monte Carlo method. Now the Monte Carlo method can certainly be applied by hand, physically, in person, or you can apply it just computationally, but today I'll be walking you through how you can implement it computationally and graphically at the same time so that you can really get a first-hand feel for how this algorithm actually works. If you want to follow along today, make sure to check out processing. That's the tool we'll be using, and I'll be showing you the website in just a second. So let's get started, shall we? Okay, so I'm here on the processing website. This is actually a really cool tool. You can use it for a lot of different things, but again, we'll be using it today to program a graphical simulation of the Monte Carlo method. So just make sure that if you're going to follow along, go ahead and just go to download and go ahead and grab that tool for whatever operating system you're on. Okay, so before we get started delving into the code, we're going to just take a second to go over how the Monte Carlo method works and how we'll be applying it today. So to start, the Monte Carlo method actually is not just one technique or method, but rather it refers to a broad class of approaches that generally involve using randomness to solve some kind of computational mathematical problem. Um, in this case, we'll be using the randomness of plotting points on a square to ascertain the area of both that square and that circle, at least relative to each other. And that's how we're going to attempt to find pi today. So, generally, we know that the area of a square is one of the sides of squared. And in this case, the area of our or the length of our square, the length of one side of the square is 2r, which is twice that of the radius of the circle, because the circle is inscribed in the square. And we also know that the area of a circle is pi r squared. So, if we substitute the values of r squared and r circle into those general formulas, we find out that basically the area of r squared is 2r squared, which is 4r squared. And the area of our circle is pi r squared, which is not surprising because we just plug r into r. So pi r squared equals pi r squared. Now, that's interesting because, again, we don't know necessarily the actual area of either of these, but what we do know is that we can ascertain an approximate area for both of them and then use that relationship to determine what pi actually is. So if we put the area of our circle over the area of our square, we find out that we basically get pi r squared over 4r squared, and the radius squared cancels, and you just are left with pi 4 or pi over 4. So whatever result we get from this estimation, we can times by 4, and we should have a pretty good approximation of pi. Now, it's not perfect, but the more points we add, ideally, the better our approximation will get. So now that we understand that, let's talk a little bit about the circles themselves. So computationally speaking, we also know that a circle is defined by the points given by x squared plus y squared equals r squared. So if we're starting with, a point, basically a circle that's defined in the center and a square, if we plot a point from the center out some distance, x, y, if that's greater than the radius of the circle squared, then we'll know that point that we're plotting, even if it's random, if we know the x, y of that point, we can determine based on that formula whether it is outside or inside the circle. And obviously, it's going to be a given that it's inside the square. So all points we plot will be inside the square. From any point inside it, it'll be any point inside the square, any x, and it can take any x and y inside the square, and then we can use that formula right there. This one right here to determine if it is inside or outside the circle. So now that we understand that, I think that should be enough to get us started. So I'm going to go switch over to processing now, and you should probably open up your editor and follow along. Okay, everyone, so I'm here in processing, and basically, you're going to want to start off with this template right here, just to make things easier. This is just going to set the size of the window that gets open, and that we're working in a 2D processing plane. And then this is just going to set the background to black. So the way this works is setup basically runs once, and then draw repeats in a loop. Now, what we're going to do here is actually we want to make sure that in the setup we call no loop, because loop happens by default. So basically, if we do this, draw will never execute until we press the mouse down. So that's what these options here are for. You know, make sure you have no loop here. That way, when we hold click, the loop will continue to work, and otherwise, or if we hold like the mouse down, the loop will continue to work, and otherwise it'll just stay static. And that'll help us get a little bit more control over how fast the simulation occurs and give us time to read the values and whatnot. So now we can actually get started. I'm going to basically just create a couple constants at the top, and then you're probably going to want to put these right here. Count is just going to give us a general rate at how fast we're going to add these points to our circle and square, and you can change that value if you want to slow down the rate that the points are added. And then we're going to use a radius of 256 for our circle. Bear in mind again that we're working on a size, basically a plane with size of 768 and 768. So I'm actually going to put a little, basically we're going to take that little black box that opens up as the actual page, or as the little application. You can click run here if you want to right now. Right now it's just a black box, so it's just, you can't really see much, but it's it's over in the corner over here. There's nothing really being drawn right now, so you can't see that. But if you want to run it yourself, at this point you would see a black box up here with just, it's just a title. But like I said, I'm going to put a square in the middle here, and so some of the computations we're going to be doing are a little bit more complicated because we have to account for that offset from the corner up here. So like I said, the radius of our circle is 256, and we're going to be using a I believe it would be somewhere around like 128 point offset from the center in order to get to the outside of the square, because the square is going to be 512 points wide and high, and obviously the circle will be the same at its what is its diameter. So yeah, again, that doesn't make sense, just hang in there. We'll get there soon. So I've already calculated the center that we need for our circle, and again, that's just the center of it's just 768 divided by 2. But in this case, I'm just going to make it easier by just typing that value in itself. Now, the other thing we need to keep track of is the list of, so I'm going to create this thing called a circle here. And now this processing has a concept of a circle, at least it can draw one, but it doesn't really have a circle type, so we're just going to create one ourselves. And that'll give us a little bit more control over how exactly this functionality works. So we're just going to do, so the code here, if you aren't familiar with Java, is going to look a lot like Java. It's not, it's got some extra functions that are visible that, but it definitely uses a Java syntax, things like the array list and stuff like that. So if you're familiar with Java, it'll make more sense. Processing actually offers a lot of different flavors of syntax, but we're using Java because that's the oldest one. It's been around a long time, and I guess you could say that's kind of like the official processing language. And then the others could be almost considered, I guess, kind of like bindings. So we're going to do circles inside and then circles outside. So we really only need to track the circles outside, which would be the number of circles in a square, and then also the circles, circles inside, which is the number of circles inside the circle, and then circles is the number of circles in the square altogether. And outside is just the difference of the two. So that's, this one here is kind of extraneous. We're just going to use it to provide a little bit of extra data to, the viewer. So let's go ahead and just build our class for our circle here. Again, this is probably some, in general, would qualify as a pretty rudimentary Java code, because if you've ever taken like some basic introductory Java classes, you've probably made like some squares or rectangles or something like that. So definitely not difficult stuff what we're doing right here. And again, some of the functions I may be using later may be like specific to processing specifically, like they're not part of Java. So if you see something that's a little confusing like that, that's why. So we're just gonna do some your standard Java constructor right here for our circle. It's nothing complicated at all. And again, we're kind of just laying a little bit of boilerplate for our actual simulation itself. So I'm just going to do draw right here. And so we're just defining a little method called draw, and this is to make it easier for us to draw circles on the inside versus the outside. Or I guess I want to draw them with different colors, in other words. So I think it'll make it easier to draw them on the inside versus the outside to do that. So if I just do, this is standard, this function here, color, takes a standard RGB. So if you're familiar with RGB, red, green, and blue, then you would, that's 250. You're gonna want, well, you can just use whatever values you want here. I'm using red and green. Obviously, I'm aware that that might present some issues for some people, so you could swap those colors out for anything you want. And I'm just going to do fill. See, so fill is what you're going to use to set the color on any object that you, I guess, are going to be calling. So in a second here, I'm also going to set this thing called no stroke. That's going to take the stroke off the edge of this type here, circle. Now, like I said, circle is different. Circle is a just primitive function that's embedded in processing, and it literally just draws on the graphics plane a circle. But it doesn't give you any handle to operate with, so that's why I wanted to keep track of some of this data. We're going to build this type right here, basically, called a circle, and use the constructor for it, and then stick that into these so that we can, have something to store. And we can also call this little draw method right here, and it does all this stuff for us, so we don't have to do that later. Yeah, and that's kind of just like a little bit slightly object-oriented approach to what could be completely solved, just with some procedural programming type problem. Especially in this case, it's not complicated either way. So the next thing we want to do here is just to start off our canvas, we're going to say we want a rectangle that takes that basically these two coordinates I'm giving it right here are the center minus the radius. So this is going to be the top left corner of the rectangle, and then the next two values we're giving it are the width and height of the rectangle. So we just set these right here. We should get a square that is perfectly in the center of our 768 by 768 window. And if I go ahead and start this, we should be able to see that. Sorry, I must have, okay, let's these semicolons up here. So we're just going to go ahead and start that up, and just to check to make sure everything's working the way we expect it to. I think I probably left some colors or something like that off, because we should be seeing a rectangle right about now. Let me go ahead and make sure that I just typed everything the way I wanted to here. Let's see, and make sure I got all of my constants right, and then yeah, so we're just going to yeah, that looks fine. So we just want to go ahead, and I think I might need to put this no loop after the rectangle. Or either that, or I may need a fill. Just put a little fill in the background. That may be what I'm actually missing. So either one. Just go ahead and, okay, there we go. So yeah, you would definitely make sure to put the no loop after the drawing operations. Just make sure to do that, otherwise you obviously won't see your square. So here, again, I've got the square in the middle of my window. You can't really see the border of the window, but I obviously have it here. I'll be putting some text in the border of the window up here. So make sure that you give yourself a little space, because that's where we're going to be outputting our actual pi numbers. So I'm going to go ahead and now stop this. And then we're going to draw our circle right on top of that. So center. Okay, here we go. Okay, there. So this basically, again, you hand it the coordinates for this is the center point of your circle. So this is just the literal center of the circle. What we could consider to be 0, 0 in our formulas. And then this is just the length across the circle. So basically, diameter is what you're providing it here. So again, we're just going to run that, and we should see a circle on top of our square. Perfect. that's exactly what we want. This is great. Now we get to the code where we actually do some of the Monte Carlo logic. So we've got our circle and our square that we want to plot on. Now we actually have to plot on the circle and square. So stop that right there, and we're going to get down to our drawing logic. Now, the drawing logic is basically, again, this is going to loop whenever we hold down the mouse, but otherwise it's not. So I think probably the first thing we want to do is just basically go ahead and start drawing some circles on the actual plane itself. So we're just going to plot random points on the plane, on the square and the circle. And then we'll be using those formulas we discussed to calculate the overall, like, position, or not position, yeah, the overall position, and see if those are going to contribute to those circles are going to contribute to the area of the square or the circle. Technically, if those circles are going to contribute solely to the area of the square or contribute to both the square and the circle is the better way to put that. So we're just going to do a basic random operation here. So this is literally just going to be, give me a random x value from the center minus our radius to the center plus our radius. Bear in mind, again, of course, this is not bounded by the x squared plus y squared equals 1 operation, so this can give us anything starting from one corner of the square to the other corner of the square. And we're just going to repeat this. And so the random function, it returns a float, and we want to make sure that we have an integer here to make some things easier for us. So that right there is going to should be enough to at least plot some circles. So I'm just going to go ahead and go straight to a circle here. And although we already added the code for is inside is outside, we're going to check that in a second. We just want to make sure our circles are plotting correctly. So put rand x, y, and then again, this should plot anywhere inside the circle over time. So I was going to put true here for now, because that's a boolean that we're providing there. So at this point, you would go circle.draw, which is that little function we defined right here. And then lastly, thing I want to do is I want to go ahead and we want to go ahead and add this to the we want to go ahead and add this to our list of total circles. And in other words, the number of circles inside the square all around. So just number of circles we've plotted all together. In other words, you could call any of these circles points, but they're technically circles the way I'm choosing to plot, or I guess graph them or show them graphically. So that's the only reason I call them circles. They're technically points for our computational purposes. And the x and y is going to represent the center of those circles, quote unquote. And then this also here, this, as you can see, when we're actually drawing it, this 5 right here is going to be the radius. Again, you can change that to a smaller value if you want more precision. I just want it to where it's actually visual, so you can actually see something. So I'm going to go ahead and we're going to go ahead and add the list of, go ahead and add our circle to the list of circles we defined above. That should do it right there. And again, you won't be able to really see the output of this, but we'll do that for now just because it makes sense to do it at this point. So basically the draw function's already run once. You can see that there's some green dots. I've plotted 100 green dots. And once we've determined whether these are inside or outside, you can see if I change this to false. So go ahead and go here, stop it, and rerun it. False plots red. And so if it's basically, if our circles are outside the circle, they will be red, and if they're inside the circle, they're green. And that's, again, just visual, just to distinguish it visually. And also, if that presents issues for you, certainly change the colors. It's not a big deal. So if you just hold down the mouse, you see we keep adding points, and that's exactly what we want to do. We should just keep adding points. So now we can stop our simulation, and then let's determine if our circles are actually inside the circle or outside the circle. That's kind of the next big thing. So let's make a little boolean called is inside. And at this point, we're going to basically go reference our thing here where it says that we can take the square, yeah, so basically what I'm going to do is take the square root of both the x value and the y value squared, and then see if it's less than or equal to the radius. So it's just a slight adjustment to this formula right here. And again, you can do it. You could probably copy the formula exactly if you want to, but so we're just gonna do square root of tau. And then make sure this is one of the things where we really have to compensate for the center of the circle. So basically, we're going to take the rand x minus the center position of the circle. And the reason we want to do that is because basically we're trying to get the radius itself. We just want the radius. So assuming that we weren't dealing with this offset position kind of stuff, we would literally just want to see how much radius we have. And whether that radius is negative or positive doesn't matter, because ultimately when we square it, that will give us an absolute value. Or yeah, it'll give us a positive value always. It'll even give us a positive representation of the negative possible value. So it's fine if we do it that way. And then this POW function is the actual way we're going to square it. So you're literally just taking rand x minus the center. Again, that's to deal with the offset issue. And then it's literally to square it. This is our square root function. And then we want to add these two powers. So I'm going to copy this and do the same thing with rand y. Add those two powers together. Take the square root and then just check to see if it's less than or equal to the radius. So we can do that. Technically, I think the better way to do it is, yeah, less than or equal to radius works. So we've determined whether it's inside now. So if we go ahead and it's inside, go ahead and save that, run it. You can see that already that it's plotted some basic points and that the inside of the circle is green and the outside of the circle is red. So it seems like it's working so far. And believe it or not, this estimation alone gives us a relatively accurate number for pi, given how we're attempting to find out what pi is. But as we add more and more points, it becomes a lot more accurate. And you can't see that yet, but as you can see as we fill this in, that our code for determining whether the points we're plotting are inside the circle, outside the circle, or it's obviously working because it's forming a shape of a circle. So now we're just going to close that there. And the last thing we need to do is count the number of circles inside or outside the circle, and then display that and do a tiny bit of math to take what is ultimately going to be our pi divided by 4, and just multiply that 4 and display that number visually. So I'm going to do circles inside, so that gives us the number of circles, or it's going to add each circle to that is if it's inside to the list of circles. So yeah, it's basically going to get each circle that is inside will be added to a list of circles, and that will give us the total count of circles inside the circle. And again, you could replace it with points. And then if it's outside, we'll just add it to the list of circles outside the circle. And again, that's different than the total circles, and we don't really need circles outside. Again, that's more or less just, again, technically it's the difference of the two. But it just provides a little bit more information to whoever is like, going to be using this application. So the last thing, now that we've done that, again, you can't see the results of that yet, but we'll get there soon. So we're just going to go ahead and set the color to black. And the reason we need to do this right here, so what we're doing right now is I'm putting a little rectangle up in the top. And I could make it white or some other color, but in fact, I'll do it just for a second so you can see. I'll make this like dark green or something like that, so 45. And I missed a semicolon, so just make sure to add your semicolons. It's Java, it's going to whine at you. So you can see at the top here, dark green, that's our header space effectively, and that's where I'm going to put our stats or statistics for our computation. So close that, and again, you can fill that with whatever color you want. If you want it to stay green, you can even leave it as a kind of bluish green right there. That's fine, it's not going to hurt anything. Now we're going to set the fill to a color of white, and this is what we're going to use to print text. So basically we set the backdrop, and you need to do this in the draw loop, otherwise these things are just going to keep printing on top of each other. There's nothing to update that space. So we're basically drawing a rectangle behind it to clear it, and then we are actually going to draw the text itself. So set the text size to 56 is more than enough to make it very easy to see. So you're just going to do text circles outside. So this is the total list of circles, and this represents the number of circles inside the square, all around. So it's just all the circles we have, and again, this also represents the number of circles inside the square. Now we're going to do fill 255, and this here, these points I'm adding work for basically the spacing, but if you want to change where the text is located, this is your x coordinate, and this one's going to be your y coordinate. So basically how far right and then how far down do you want your text to appear. And so yeah, now we want our we've got our fill, so we just want to put the circles text. So at this point, I'm going to make this say circles inside. And I might have gotten my... Did I get my colors backwards? I could have gotten my colors backwards. It's fine if I did. Yeah. Pretty certain. Oh, okay, anyway. Yeah, so if I got my colors backwards, we'll just fix it. I can't quite tell at this point, so it's fine if I got it a little wrong. And then now do circles outside. So circles outside. Yeah, I might have got those colors backwards, but it's fine. Again, if I did, we'll see in a second, and it'll work just fine. So now we're going to set this text here. The last text we need is we're just going to set it to white, and that's going to be, we're going to put this text that I'm writing right here below everything else, and that's actually us solving for pi. So these values here, in fact, I'll just show you them right now. Don't need to solve the last thing yet. So, what did I miss? Oh, there we go. Make sure to set your, also, yeah, you're going to want to make sure to put these spaces here. I forgot to add these, so just make sure to throw those on there, and that'll give you the actual positioning that you need. Otherwise, again, you may run into some like overlap errors. So if I hold it down right here, you can see some colors we have on the top. Hold that down. These represent different numbers, and what we would expect is that the circles outside would be much smaller, and circles outside should be red, but the circles inside should be green. So just make that, set that like that. There we go. And then when I restart this, we should have the correct number of, there we go, perfect. So we should have the correct number of circles on both the outside and inside. And again, we don't really need to know the number of circles on the outside, but I think it's helpful. It just provides a little bit better graphical understanding of what you're seeing here. Finally, again, we're going to solve for pi itself, and that's just based on the division of this number right here. So make sure, yeah, you're basically going to take the area of your circle. So we're basically taking these points and approximating the area by saying I have this many points. If I just flatly uniformly distribute points across this entire space, and then I basically say, oh, I have this many points inside the circle and this many points outside the circle, or this many points total technically. That's going to make up the areas of our circle and our square. Then we just put this over this value right here, and that plugs into the area of our square and area of our circle equation we have. So I'll show you right here. Yeah, the area of our square and area of our circle. So we just plug right in that equation, and we get pi over 4. So we're just going to come down here, and we're actually going to do that calculation now. So string right here, this is so we can convert some floats to strings, because again, we're solving for a float. Pi is obviously a float. So circles inside that size, and then divide that by the we're casting each of these to floats to make sure they divide properly, because otherwise they may perform integer division, which would give us a really square number, probably like 3. And I mean, yeah, that's pretty close to pi, but you really want more precision than that. So again, these last values I'm just putting here are the properties to the text. So these are just going to go into the so technically, if you want to make this easier to understand, you can just go ahead and go something like, you know, string, or like it might be string text equals, and just go down here and pass text in. So we're going to go ahead and run our equation, our thing again, and forgot to put my semicolon there. So let's go ahead and that. And there we go. So even just using 100 points here, we see that we already have 3.04 as an estimation for pi. And if you hold down the mouse button, see as it fills up very quickly, that we get more and more accurately close to pi. So we both well know 3.14 is pretty close to pi, and the more points we're adding, it's kind of seeming to become more accurate. And again, it's a Monte Carlo estimation is an approximation, so it's not exactly accurate. And you also have to realize that we're using a certain fine point number of like physical points in this code, 768, both link-wise. So you're only going to get so much accuracy out of this code specifically. If you were using floating points for this entire calculation, it would probably be a bit more accurate. But the reason we're doing it this way is to demonstrate it graphically. So that's it. I hope you found this to be very entertaining. And if not, you know, at least hopefully you still learned something. If you enjoy this content, make sure to like and subscribe, and I will be posting a link to this code in the description below.